Now, to have a quick understanding about the main concept or structure of susceptibility mapping, here we will do a quick review about the general steps of the modeling. So first, susceptibility mapping in general consists of data and analysis model and the results representation and the validation. In data, in general, we have the independence and the dependent factor. So the independence, usually it can be a categorical or continuous, which is consist of the topographic maps from the digital elevation models like slopes, aspects, curvature, as well as distance from roads, or the categorical data which is presented by geological data or land uses or soils, as well as the dependent, which is represent our target, for example, as landslides locations, floods, or some minerals locations, which usually represented by either points or polygons, depend on the quality of the data. And then you have the analysis model, which can be any sort of statistical mathematical models, bivariate, multivariate, using artificial intelligence, fuzzy logic, and decision tree, and or ensemble algorithm, and so on. After that, you will have to represent the results using the cartographic skills, and then do the validation, which there is a lot of methods also to do. Check the models itself, the analysis itself, using the statistical tests that it's already equipped with the methods, or using the ROC, and so on. Usually we have this question that it's come along with the analysis. So usually we have a target to say how to increase the results accuracy level. So it can be through many points, especially about representation types, or as we said, the dependent data. So it can be points or polygon. Using one of them, it can affect the result, either the mapping units and the size and the shape. So when we have a clear polygons that is represent the events, if it's, for example, slow failures, so the shape of those units or the size can affect the result positively. Or if you deal with the mineral potentials, you have just boreholes, or you have just points. As well as when we do the multivariates or the fuzzy or decision trees or ensembles, usually the data should be a binary data, should be 0 and 1, the one that represent the events, the location of the targets. But the 0, it's referred to the free area or free slides, or the areas that you are not expecting to have the target occur there. So how to select these free areas, which it has too many methods that usually in the literature fed it up, or are not mentioned clearly. So in this course we will mention how to produce the free landslides area. We will focus here on some slides data, and then about the sampling methods. So usually when you do like random methods, you classify your data to 30, 70, 40, 60, or you do geographical sampling methods. You are taking, for example, north of the study area to train, and using the south to test, and so on. Or temporal data, so you are taking 5-6 years before, and you take after that 2 years after to test your model. So it's different sampling methods, and by sure, if you have more data, you can increase the result accuracy. So in general, the methods that especially focusing about data preparation, usually if you take it as a manual construction of this data. It's a time consuming, and as well as moving the data from Excel to the another software, to the, for example, to the QGIS. After that you have some work with the ArcGIS, or you're dealing with the ASCII file. So it will aggregate the uncertainty. So in the current course we will try to focus on developing the training data within the same interface, within the same software, the same package, using the developed tool. So at the end of this course you will have a data will be look like this table. You will have your dependent factor represented by unit of 1 and 0, and you have the other independent factors like terrain roughness, or TWI, or elevation, curvature, or whatever, and they will be represented all together. So this data now it's ready to be inserted with any package that either with R or with SPSS to be used to next level for the analysis algorithm. So if you see here, we will talk as well about if you have the categorical data, what's kind of result you need to add, or if it's continuous data, what kind of result or what kind of data or value you need to add in this table. So we'll explain this comprehensively when we demonstrate the tools itself. So based on the literature, all we know that the past is the key to the future. So what happened before in any specific area might probably happen again when the previous circumstances met. So this is the basic understanding for whatever happened when we are using the susceptibility mapping. So we depend on the historical data to produce something that will be valid to be used on the future. So based on this, some places that never have witnessed landslides, for example, will never develop such kind of events again, or will never have the chance to develop or witness the landslides. So here, for example, if we talk about what is the free slides area that we donated as the 0 value. As you know, the value of 1, it's already well known. It's the target, the data that we have. But the big issue, it's about the free areas, which is the literature is not clearly mentioned about. So for example, the literature mentioned about for example, the slopes less than 5 degrees. And how to select the landslides free area, for example, either randomly or specially. But there's some information missing about the approximate areas of these free objects of the non-landslides training data. How to choose which kind of area, because the number, as we generally take the number of 1 or the target should be equal to the number of zeros. Alright, in case we have a points, then there is no problem. But if we have a polygons, so the number of polygons as well as the areas of these polygons should be equal to the number and areas of those zeros values. So we start with the mapping unit, which is the mapping unit is the smallest and non-separable spatial entity. With any kind of mapping, it is the smallest unit represented by, if we have a raster, it is the pixel size. So the accuracy of the data depend on the partitioning of the mapping unit. So those units should be as small as it can reflect or tell us what kind of objects do we have. That means it should be the smallest units, because if we have some objects smaller than the mapping units, it won't be able to show this object. So logically it should be the smallest unit. So in the literature, actually the main 5 types of, or the main 5 mapping units represented by the most common mapping units are the grid cells. and slope units, terrain units, and unique condition units and topographic units. Here, choosing the units itself, it can add a great value to the susceptibility zoning result. Also, the mapping unit should maximize the internal homogeneity. So if the data that is not homogeneous, you can't have a clear prediction about what is going on. Usually in the literature, the best compromise between landslide size and landslide conditioning variables use a range of spatial resolution. For example, if we take the pixel size, let's make it this way. If we have the pixel size 50 to 100 meter, that's mean the side. That's mean if it's a square, 50 multiplied by 50 or 100 multiplied by 100. The accuracy or the area under curve will be within 80%. So this is in general, if we have like 50 to 100, you can't expect more than this, more than 80 or 85. That's because, as we will come to explain, it's depend on the scale. When you take it 50 to 100 meter, you expect that the scale that you are working on now, it's going to be larger. So then the accuracy that you have the objects will be limited. So there is a lot of things will be generalized. So what kind of factors that mapping unit depend on? It's the type of landslides phenomena. If you have many different type of landslides or different type of events that happen on the surface, so we need to have these units to be represent these events as close as possible. So for example, if we have landslide, for example, the shape of the unit cannot be square, because landslide won't happen as a square. So if we say that the grid is the best for landslide, this is a not correct statement. The unit that represent the event should be as close as to the natural representation. Also the scale of the investigation. So our scale here, if we have the high precision satellite image and we have very good landslide data or mineral data, and it's the high resolution collected by LiDAR or field inspection, we can go for the appropriate scale. Also the quality and resolution which usually connected to the scale. Also what kind of data that we are looking for based on the thematic information, and so on. Here if you see in this table that I mentioned the article that it's quoted from, if we are making the scale to be small or medium or large, if you are confused about your study area size and what type of scale you think it can fit with this data, so this table can serve this understanding. For example, if your scale is considered to be within 1 to 100,000, and this is considered to be small scale, and that useful, for example, in landslide inventory and susceptibility mapping to inform policy makers. You see, it's on general public. So this is a general assessment. Why? Because here the typical area for the small scale, it's will be more than 10,000 kilometers square. So it is just for regional zoning. The study area scale will then 100,000. If we talk about medium scale, this is the most common scale actually for landslides, especially but available. So 100 to 25,000. So this kind of analysis will be basic, applicable, and it can be used for the susceptibility mapping or very large scale. So the study area will be within 1,000 to 10,000 kilometers square. Yes, this data will be informative, but it cannot be used for example, risk assessment or the vulnerability of the land uses. While the large scale within 25 to 5,000, and this is we call it high resolution data. It can be using for basic, intermediate, and advanced zoning methods. It can be used for the hazard and risk, as we said. So the data, the study area will be 10 to 1,000 kilometers square. So this table, actually, it can give you the insight about putting a correct scale. Then you understand the output. Too many researchers assume that their result can be used for risk assessment, while they use medium scale or small scale. Okay, so here this can give us more accurate conclusion about the results that we present.